Everyone knows about the capacitor. The capacitor is a device that that is used to store the electrical charges or static charges under the application of external potential. Okay, under the application of external potential, the charges are stored on the plates of capacitor depending upon its capacity or capacitance. Okay, if a particular capacitor is having a more capacity, then it is able to store the more charges. Now we have to solve this circuit containing single capacitor using J operator method. Okay, using the J operator method, we always know that the initially we have to apply the AC voltage to the circuit. Here let an alternating EMF E equals to E0 sin omega t be applied to pure capacitor having capacitance or capacity C. Now we know E equals to E0 sin omega t be an imaginary part of the complex number E equals to E0 e to the power j omega t, and hence the complex EMF applied to the circuit is E equals to capital E0 small e to the power j omega t. That is our equation number 1. uh, we have used the same paragraph for 3 articles. Okay, because it is much simpler for you to write any article. Because okay, so just you have to change here the name of that device, and the first paragraph in these 3 articles, previous 2 articles and this article, are same. Okay, so they are very much simple for you to write or start the any article. Okay, so equation 1 gives you the value of applied EMF to the circuit containing capacitor only. So what happens with the application of this AC voltage? Okay, the current I is flows in the circuit, and due to the current I, the charges are accumulated on the plates of capacitor. So on the first plate, suppose if the positive charges are accumulated for the instant of time, then on the other plate the negative charges were accumulated or developed. Okay, and so on. So these two charges, uh, opposite charges develop on the plates of capacitor, are always proportional to or always depends upon the strength of potential or applied AC voltage. Okay, now due to the applied voltage E, the instantaneous charge developed on the plates of capacitor is, suppose Q. Let Q be the charges developed on the plates of capacitor. Okay, it may be positive charges on the first plate, negative charges on the second plate, and so on. Okay, so the charges developed on the plates of capacitor will be Q, and as I have told to you that the charges developed on the plates of capacitor are directly proportional to the applied voltage or applied EMF. Then in this equation, if we remove the sign of proportionality, put equal to sign and put the constant, that is called C, means the capacity or capacitance of the condenser or capacitor. Okay, it is a very general equation, that is Q equals to C into E, or sometimes V is used as a potential. So from this equation we can define the capacity. Capacity can be written as C equals to Q upon E, means instantaneous charges developed on the plates of capacitor per unit potential difference is called capacity of the capacitor. Okay, as the charges develops on the plates of capacitor are directly proportional to E, so their ratio is constant. Thereby the capacity of capacitor is constant quantity depending upon the construction of the capacitor. Okay, as soon as or as the capacitor is synthesized, its capacity is decided or fixed. Okay, it is not changed by anything after fabrication. Now we know the value of E, that is capital E, from the equation 1, that is applied voltage is E0 e to the power j omega t. So equation become Q equals to C E0 e to the power j omega t. Every time you must have to remember about our final target. We have to solve the circuit containing capacitor, means we have to find out, finally we have to find out the value of instantaneous charge and instantaneous current flows in the circuit. Okay, because in case of pure resistor, pure inductor, we have initially applied the AC EMF to the circuit, and after solving that circuit and by making some calculations, finally we have calculated or derived the equation for instantaneous current in the circuit. Okay, now in this article also our aim is to determine the instantaneous current I that is flows in the circuit. Okay, so here current I is flows in the circuit due to the application of external potential or EMF E. Okay, so this, now let us differentiate this equation 2. Here equation 2 will be Q equals to C E0 small e to the power j omega t. Okay, differentiate with respect to time. What happens? So q will be differentiated as dq by dt. C is a constant quantity, e0 is a constant quantity. Then differentiation of e to the power j omega t will be e to the power j omega t into derivative of the power, that is j omega t will be j omega. Okay, so its differentiation will be c e0 j omega into e to the power j omega t. Okay, now take this j omega in front of the term. Okay, we have taken this j omega in front. So equation for dq by dt, we know rate of change of charges per unit time, that is called current. Okay, so in place of dq by dt, we have substituted I equal to j omega c into e0 into e to the power j omega t. Okay, that is our equation number 3. As equation 3 contains the imaginary number, that is j. J is having a value of under root of -1. So we need to change, or we need to replace this j by something. Okay, thereby we can solve the circuit. So we know j equals to, j can be written as we have used in the previous article, as j equals to 0 plus j. Okay, 0 plus j. So in place of 0, we can, I have substituted here cos pi by 2, because cos of 90 degree, that is cos pi by 2 is 0 plus j as it is into 1. We can write j as a 0 plus j into 1. In place of 1, I have written here sin pi by 2, because we know sin pi by 2 or sin of 90 degree equal to 1. So j can be sorry written as cos pi by 2 equivalent to 0 plus j into sin pi by 2. Sin pi by 2 is 1. Okay, so equation for j equals to cos pi by 2 plus j sin pi by 2. We know the De Moivre's theorem, as I think you have used in the mathematics complex algebra, which is cos theta plus j sin theta or I sin theta equals to e to the power I theta. Okay, in this case I is similar to here j, therefore j equals to, it can be written as j equals to e to the power j pi by 2. Here in place of theta, pi by 2 is there, so j can be written as e to the power j pi by 2. Here value of j is remains unchanged. Okay, just we have converted that 0 into cos pi by 2 and 1 into sin pi by 2. Okay, for the sake of our simplicity. Now put the value of this j in equation number 3. In place of j, we can substitute here e to the power j pi by 2. So other terms are as it is, I equals to omega c as it is, e0 e to the power j omega t also kept as it is. In place of j, we have substituted here e to the power j pi by 2. Okay. Again, this omega c can be written as 1 upon or E0 divided by 1 upon omega c. So 1 upon omega c will be omega c. So E0 omega c can be written as 1 by omega c. Here the base of E as it is, and base of here both the terms are same E, and j from both the terms are taken common. So quantity will be inside the bracket will be omega t plus pi by 2. So this equation can be simplified to the this form, that is I equal to E0 upon 1 by omega c into e to the power j in bracket omega t plus pi by 2. Okay. Now the quantity 1 by omega c is equivalent to the opposition to AC signal called capacitive reactance. In case of the inductor, the opposition of inductor to the flow of AC current will be XC denoted by XL. XL equals to omega into L. Okay. But in case of capacitor, the quantity 1 upon omega C is called capacitive reactance denoted by Xc. So Xc can be written as 1 upon omega C equals to 1 upon omega, value of omega will be twice pi f c as it is. So this quantity xc equals to 1 by omega c equal to 1 upon twice pi fc is called capacitive reactance. And as we know, it is reactance is inversely proportional to frequency, whereas in case of inductors the reactance is directly proportional to frequency. Okay, where f is called the frequency of AC signal that is applied to the circuit. So after substituting 1 by omega c equals to xc, the equation previous equation, this equation can be written as I as it is equals to E0 upon, in place of omega c, let us substitute here xc, and all the other terms are kept as it is. Okay. So the equation changes to the form I equal to E0 upon xc e to the power j in bracket omega t plus pi by 2. As we know, xc is opposition to the flow of AC signal or AC current, and it is again analogous to the resistance. So in this equation, E0 is equivalent to the, or it is a amplitude or peak value of the voltage divided by Xc is a quantity equivalent to resistance. So ratio of voltage to resistance, that is called current, or denoted by I0, called the amplitude or here I am PLI. Okay. Amplitude or peak value of instantaneous current. Okay, this equation is also similar to the previous equation, only difference is that there xl is substituted, here xl is replaced by xc. Okay, so ratio of this peak value of voltage to the quantity that is analogous to the resistance is called, denoted by I0, called the amplitude or peak value of instantaneous current. So just substitute in this above equation. So the equation can be written as E equals to, oh, I think I have, okay. This equation is written in the equation number 4. Okay. Here 4, I have directly taken, substituted this quantity above equation. So the equation will be I equals to I0 e to the power j omega t plus pi by 2. Okay, so it is our equation number 4. So here equation 4 is the value of instantaneous current that is obtained in the circuit or developed in a circuit. Again, I have mentioned here equation 1, which is our applied AC voltage. Whenever we compare the equation 1 with equation 4, so E will be analogous to I, that is having a same phase, no change. E0 is analogous to I0. If we compare the value of I0, so I0 will be equals to E0 upon XC, means it is obviously less than the amplitude of AC voltage. So whenever the AC voltage is applied to the pure capacitive circuit, the amplitude of instantaneous current decreases by some factor. Whenever we compare the phase, here the phase of AC voltage will be omega t and phase of the AC current will be omega t plus pi by 2. So phase of the AC current is more than that of the AC voltage. So from equations 1 and 4, it is clear that the current in pure capacitive circuit leads the applied EMF by a phase of 90 degree or pi by 2. Okay, here current leads the applied EMF. Current leads the applied EMF, whereas in case of inductor, pure inductor, current lags behind the applied EMF, because in that case here the phase of current will be omega t minus pi by 2. In case of pure capacitor, phase will be omega t plus pi by 2. So in this case current in pure capacitive circuit leads the applied EMF by a phase of 90 degree or pi by 2. Okay, we can also draw the phase relationship between instantaneous current and the applied EMF in a simple way. We can also write this as on the y-axis, suppose whenever we mention here the voltage E, okay, and when the voltage phase of the voltage E is suppose 0 at this instant of time, then whenever we increase the phase by here pi by 2, phase of pi by 2, then along the x-axis we can write here instantaneous current. Okay, so it is a simple way of expressing the phase relationship. Also, we can show the phase relationship like this. Suppose it is our waveform for the AC voltage. Okay, AC voltage denoted by E. Then the waveform for AC current will be like this. Okay, means here the phase difference between, here it is the waveform for the AC current denoted by I. So AC voltage starts from 0 phase, whereas AC current starts from a phase of pi by 2. Okay, here a phase of pi by 2 is there. Okay, so in this way we can show the phase relationship between current and voltage, but it is not compulsory to show the phase relationship. Whenever we just mention these lines, that means from the equations 1 and 4, it is clear that the phase in or current in pure capacitive circuit leads the applied EMF by a phase of 90 degree or pi by 2, then it is sufficient. Okay, so it is about the today's topic. Thank you very much. Now you can ask me any difficulties if you have about the today's topic. Anybody has any difficulty?